Hi, everyone, and welcome. I'm very pleased and honored to be speaking at your user group today. We've got a really interesting subject to talk about, and that is an introduction to AKS security best practices. What this means is if you are new to AKS or moving from a development version of AKS and looking at what you would need for security in a production environment, I think this will be the talk for you. We'll go over lots of little tips as we go along, and hopefully one or more of them will be of interest to you as we proceed through. So, first of all, who am I? My name is Stephen Pope. I work for a company called Clued In, and I am a principal cloud engineer. I deal with anything to do with the cloud in the company. The idea is I get the application from the developers and make it work in various different cloud environments. Clued In is a small startup. Started in Denmark, but now, as you can see, we are kind of spreading out into lots of different locations as we go along. We've only been around since 2016, founded by three ex-Sitecore employees, Pierre, Tim, and Martin, and now we've got around about 50 employees in total across the globe, and we've got a lot of customers around the globe as well in lots of different locations, and we are ever growing. Clued In's main role is in what's called the MDM market, the master data management, or as we like to term it, modern data management, which involves ingesting and processing and making the highest fidelity version of any data brought into it. We have a lot of customers with a lot of data in a lot of different places, and the idea is to bring that all together. So what does that kind of mean for for us? Well, Clued In is quite a complicated application, and also it is entirely cloud-based, which means we've been a very, very kind of early adopter of containers and also Kubernetes for our distribution of that. We are connecting to a lot of different places. We're connecting to lots of different data sources, different networks, bringing in all sorts of data, structured, unstructured. We are building relationships inside a graph database, and we're extracting things from files and all sorts of things. So we have quite a complicated application. Like I say, Kubernetes is the perfect kind of deployment environment for us. And a lot of our customers, and while we try and be sort of cloud agnostic in terms of our distribution, the majority of our customers are running on AKS and on Azure, and we try and make the most of Azure services, and we work very closely with Microsoft to ensure that as well. If we very just quickly look at some of our customers as well, bringing the focus back down to security, we've been in a lot of situations where data sovereignty and the protection of data is extremely important for our customers, but it does mean that we have to deploy Clued in lots and lots of different sort of security scenarios. If you think of a bank, or where we've got a lot of sensitive customer data that we're trying to bring in and process and other things, the security setup that we have for Clued In has got to be good, but also it's got to be flexible and be able to change and other things like that. And so what I'm going to talk about today really is, the sort of learning that I've got from a lot of these processes, working with our customers and also working alongside Microsoft to get their recommendations as we go through and look at things in different sort of environments. So what we're going to talk about today, what is on the menu? Well, we're going to look at a standard AKS install. When you first install AKS, what do you get out of the box? But with that focus on security and how things are working together. But then we're going to look at what AKS offer, what Microsoft offer is through a completely private AKS cluster, and the advantages and disadvantages of each. And we'll look at the complexities that come with it. But in the name of security, it's down to you guys to decide whether it's kind of worth it, or whether you've got any kind of regulatory compliance to to stick with as well. We'll look very quickly at log analytics and container insights, nothing terribly to do with security, but they are very kind of useful. And then we'll look at how, when we've got our cluster up and running, we can use a service like keyvault to actually manage our Kubernetes secrets if we want to. So instead of storing them in Kubernetes, we can keep them in keyvault and manage them through there, through maybe an existing process that exists already, like I say. Then we're going to look very quickly at container security. You can't really look at Kubernetes without looking at that. Containers are the building block of our deployments. So getting the security right there really reflects then through the rest of the system. And finally, we'll have a very brief look at Azure policies. So these are very kind of specific, but they do help if you are in certain scenarios. So they are useful to have an understanding of what exists and how best to use them. So the first thing we're going to look at is the standard AKS install, what you get out of the box with a default kind of installation with no kind of bells and whistles, and also how this differs from a normal sort of bare metal or otherwise Kubernetes install. So if we think of a normal Kubernetes install, it exists of a control plane, which is going to contain our etcd, our scheduler, and our API server. And then we're going to have various numbers from that point of workers. And these contain our containers and also the kubelet, which is going to schedule the containers on the different nodes and everything else like that. Now, in the case of AKS and Azure, the control plane is inside and managed by Azure. Hence, it is a managed Kubernetes instance, which means the API server, schedule, etcd, all of that sort of stuff, you don't have to worry about. That is taken care of by Microsoft. And then your AKS cluster sits outside in a VNet if you want it to, but we have these ideas of node pools. You have a system node pool. This can contain all the internal Kubernetes features if you want to kind of have them completely separated. And then the user node pools are where we can schedule our other containers to live. And we can have things like auto scaling and lots of other really nice features. But the separation of those two things is important. And obviously, we are the API server, which is going to control the AKS cluster, is going to be talking through to there. Now, with the default install, what happens is your API server will get assigned a public IP. Now, the normal way, obviously, to interact with Kubernetes is through the kubectl control. If you're administrating it, starting pods, scheduling things, trying to find information about the system, doing your deployments or other things, your kubeconfig, which is your, the certificate effectively that kubectl uses, is going to be talking to this public endpoint through a public IP that goes into our API server, and then that talks to the AKS cluster. That's absolutely fine. Now, like I said, when you do the AKS get credentials, you'll be given your kubeconfig, and that is a secure way of doing it. You have a shared key, a strong key, so that you can't just connect to a random person can't connect to your API server and start doing things. It is very secure, but it is going across the public internet. So there is a slight risk. Let's say, for example, somebody accidentally takes that kubeconfig and uploads it somewhere, or checks it into GitHub accidentally, or something else like that. So there is a slight risk there. So really, the first thing to look at, and the first sort of tip for this, is to restrict access to that API server. Now, in AKS, it's very easy to do via the portal. If you go into the settings, into the network tab, there's a little tick box that says set authorized IP ranges. And in there, you can set single IP addresses, or you can set an IP range in the CIDR format, which will give us an IP range. And that gives us really good control over there, and make sure that we know who is connecting, and they are connecting from known places. Now, the great thing about this is obviously it gives us access, it's completely restricted to known IPs. And this is fantastic, especially if everyone's connecting through, let's say, a corporate VPN where everyone is in within a known range, and you would know what IPs are connecting to that. The only negative here really comes if you don't have a corporate a VPN, or there are lots and lots of different locations trying to connect, or smaller individuals maybe at home, through ISPs or whatever. It depends on the company's policy. But if these change a lot, it can be painful to have to kind of go in and change these all the time, and so on and so forth. And this may be seen as not secure, and may not pass some compliance regulations because you do not have a full control, a tighter control over who's connecting it. You may put in too wide a range of IP addresses. I don't know. I mean, it's entirely down to entirely down to you and your customers, and the restrictions that are on there. So it's not 100%. So we can further secure it. So as well as the API server, which you connect publicly to, a lot of the time, especially if you're a web application, which as part of Clued In, we have a web front end, is we use a public load balancer, and this is how people connect to the system. And again, this uses another public IP which people can connect on. This again opens up a potential vector for attack. And that's when people are, as soon as we spin up an AKS cluster, we can see automated attacks coming in, just little things like trying to test usernames and passwords, and other things like that. Now, Microsoft do offer a way of putting in what they call their application gateway ingress controller. So that means that we can go into the portal again in that same networking tab and enable the ingress controller. Now, obviously, there is a charge for this, as it is another Azure service that you are spinning up. But this application gateway will sit there, and then you can start applying what they call the WAF, or web application firewall rules, to be able to kind of filter traffic and stop bad requests, or if you're getting a lot of traffic from a bad source or an attacker, you can block these at that kind of firewall level. You can do it through the portal, or you can do it through AZ. The application gateway is seen as what they call an add-on, and you can just enable that add-on through the command line if you want. But you do have to set up the application gateway service first of all, and then get the ID from that. In the normal sort of way, where you do it with an ARM template, or do it through the portal as normal. So it is also possible to install the app gateway ingress through via a Helm chart if you want to do it that way as part of your sort of automated deployments. So this now means that as traffic comes in through the public IP, it then passes through, like I say, that web application gateway, which is going to have rules in it to stop and allow certain types of traffic, both in and out of the cluster. And you can monitor that and tweak that over time. Look at the logs, look at the addresses being hit, and make sure that all of that traffic is good. They're not trying to get to anything that they shouldn't get to. And block anything in that way. It takes a little while to kind of understand and train it, and understand what you need to understand what those what are the good requests and the bad requests. There are some things might have applications that might need to phone home, or connect to other services, check for updates, etc. That you need to allow. So it'll be this kind of gradual sort of process. Once that is installed, you can then, inside your ingress, you can actually set this as the main ingress class. So if you look there on the annotations, we've assigned the application gateway as the main ingress class, and that means that Kubernetes will use that too. Personally, we've used a mix of this, where we've used the web application gateway, but we've used another ingress controller, such as HA Proxy or Nginx, to be able to do things. Microsoft obviously recommends you use the full suite here, because it gives them the sort of it gives it the full sort of control. But that how you mix and matches is down to you. But that will mean that all ingress controls all understand and know how to talk to that web application gateway. So the other interesting thing you can do with a web application is obviously put rules in place to be able to do different routes. So if we had 3 different tenants sitting on 3 different namespaces, what we can do is start creating these web application firewall rules, which sort of say, well, I'm going to have a HTTP listener, and I'm going to, send that traffic to a particular set of backend pools, backend pods, and then we can route traffic through and start to do sort of cleverer stuff with it. So there are advantages to having it. It is a more obviously you can manage it through the portal. It's pretty easy to understand, and it's fairly sort of standard stuff. And it means that you can have some more sort of complicated scenarios that you might not have had before, or if you were using something like HA proxy or Nginx, those things would need to be done in HA proxy configs and other things, which can get a little bit complicated over time. So it is a useful thing to know. And like I say, also the the tracing and logging and monitoring of it is really good. So my second tip is to at least investigate the application gateway controller. It gives good protection. You also get health probes on those endpoints, being able to kind of do different routing if things are offline. And then obviously it's very configurable, and you can do all that through the Azure portal, which is also a nice advantage there. There is an additional cost to running it. And like I say, if you use the ingress usage as well, you're kind of locked into Microsoft for the ingress. So in terms of Clued In, for example, we try and be cloud agnostic wherever we can. So tying into that for our ingress controller means that we are limited in terms of installing onto other cloud providers. But if you're using Microsoft and you want to take full advantage of it, then absolutely, then you should go ahead with that. And like I say, it just takes a little while to train all the rules and have them in place and understand good and bad traffic, but that's just the normal bedding in process of a normal sort of application firewall anyway. So it should give you good control. So with those 2 tips for a standard install, controlling the API server IP addresses, and then putting in the application gateway, all your publicly exposed parts of the system have some controls in it. And as we move on to the private AKS cluster, we'll see that we can go even more secure and even more paranoid than before. So a private AKS cluster works a little bit differently. It's a little bit more complicated. So here we go. If you remember our previous diagram, we connect through the public IP to the API server. This then allows us to control our AKS cluster. So if you're using kubectl, that's how we connect. Yes, it is protected by a certificate, but we could, we may need to be more secure. So with a fully private AKS cluster, we now start to need to create and connect to the API server via what's called an Azure private link. For that, we need a network interface inside the same subnet, and then we need a private endpoint. And what happens is the private link connects to that private endpoint, and now we connect entirely privately to the API server. So none of the traffic, none of those commands or anything going to the API server, none of those requests are going anywhere near the public internet. It's entirely private Microsoft address space. So we've created an AKS subnet that everything sort of lives in. Everything is inside the VNet, and obviously all these subnets can talk to other subnets and other things like that. But it's just for the sake of tidiness, you'll see me create various different subnets as we go along. But that private endpoint and that private link means now all communication with the API server is done through that. So the issue there then is, well, how do we talk? How do we start to issue our kubectl commands? How do we talk to that API server now that it is entirely private? Well, to do that, we need what's called a jump box. A jump box is just is pretty much a VM. And the VM is used to connect to that private AKS cluster so that we can issue those commands. So again, we have a new VM subnet that exists. Obviously, they can talk to each other because they're in the same VNet. But again, we've got a network interface on there, which we use to connect to that VM, a Linux VM, and then we're able to talk to that AKS cluster and issue our commands and other things like that. But that's not the last step, because how do we connect to our jump box? Well, if we move our jump box over to the left, we start to look at services like Bastion, Azure Bastion. It's another Microsoft service, but this provides if you're connected to a Windows server, RDP, but normally SSH connections with a VM. So for us, we're doing everything in Linux. So this is going to be an SSH connection over SSL. The Azure Bastion instance is going to need a public IP, absolutely. But then we're going to use the Azure portal, so we can log in via the Azure portal over SSL. So we've logged in with our proper credentials and everything else like that. We can then open up Azure Bastion, and this will then connect us through via SSH to our jump box. Once we're in our jump box, we are then in the right network. We're in that main VNet that our excuse me, that our AKS cluster is on, and we can talk and start issuing commands on there. There's a few more things that we are going to need. The VM box needs storage. So again, because we don't want anything going over the private internet, we're going to have to create another private link and a private endpoint to talk to that. But that's just another extension of that point. Now, if we come back to our private AKS cluster, if we do want to connect any other services, let's say a keyvault or a private container registry, because we don't want any data coming in and out of that public using the public internet. We're going to want private links and private endpoints for all of those things. So if we want a key vault, it's going to be a private endpoint and a private link over to that key vault. The private container registry is going to need what's called the premium version of the Azure Container Registry, which allows us to connect to private links. So obviously this is sort of extra costs and other things like that. So the scenario is most people would connect via SSL through the Azure portal and do all of the commands there. There is also an AZ run command where you can which sort of does this sort of thing for you, but it's quite difficult to use on the command line, and it's better to do it through a proper sort of shell session. So Azure Bastion is a really good way to do that. Again, it's another service. There is an extra cost for running that, but now you've got this idea that you've got very high security. That jump box and Bastion is going to give you a very sort of controllable entry point into the system. If you've got a team of people who need to manage that, they are all connecting to that same jump box. In terms of the IP management and the other things, that can be handled by Azure or through Active Directory inside of Azure, depending on how you've set up the users. And also, if you use a private registry, private key vault, all of those things, no data is moving across the public internet. So for us at Clued In, if you're dealing with banks or sort of certain air gap systems, but generally if you're dealing with kind of personal information, a private AKS cluster is a good configuration to consider. So there is obviously the overhead. It is more complex to set up. There are a lot of extra costs for these private links, the premium SKUs of certain services like Azure Container Registry. And also then you need to start thinking about good strategies for, if you're building containers as part of your CI/CD process, how do you get those containers into that private registry? A lot of the time your private registry would reach out to how do you push those images in securely, whereas normally things would just reach out and grab things like from Docker or from your own normal publicly accessible ACR. So these extra sort of considerations that we need to have. But this is why I say for tip number 3, investigate private AKS for production. A lot of the time the effort that you're putting in for development is a private AKS cluster a lot of the time may be too much, especially if things are moving very quickly. You're still trying to work out the scale and size of your system. How many resources, how many pods, how many nodes you're going to need, how is auto scaling work, all of that kind of stuff. But it is good practice to get into there. Also, you'll see later we can make security changes to the nodes themselves, and that actually needs a jump box anyway. So as you're sort of tightening the security on all of these things, the private AKS cluster is a very good sort of place to be. But like I say, it's the extra overhead of the costs and the complexity that you just need to weigh in the balance there. We'll have a very quick look at log analytics and container insights as we go through. So log analytics connects to an existing log analytics workspace. When you're creating the cluster, you can add it as an add-on called monitoring, like I say, and you just provide the workspace resource ID of that. Now, Container Insights is going to give us some nice metrics in terms of memory, CPU usage, but also logs from that system. One word of warning, I guess, is that Log Analytics now is charged per gigabyte of data. So make sure that when your logs are outputting, you know what they're outputting. If they're outputting in trace mode, if you leave that running for a couple of days, you could come back to a pretty spectacular bill, things like that. But it really does give a good look in. The other thing to mention really is something that's changed quite recently, I think, is if you go into the portal, into the AKS node that you're looking at, if you go to diagnose and solve problems, this section seems to have been completely revamped recently. Like it's really, really useful now. So from what I gather from speaking to Microsoft people is this now contains a section of tools which effectively the internal people at Microsoft, their support team, sort of use, and they've started to surface them as part of this diagnose and solve problems area in here. And you can go in and you can pick certain things if you're having problems, but also it does some things like I say, you can see there it says best practices. You can dig in to, let's say, identity and security, as I did here, and it will give you information on whether your certificates are up to date, whether there's any issues that it can find. And this is actually a really quick way of finding and diagnosing little problems in the system, and it's really useful to just kind of keep an eye on. So even if you didn't want to go with the log analytics, I really would recommend having a look at these diagnostic parts. If you haven't looked at them for a while, they were quite useless in the past, but now they seem to be really good. And obviously, you can set time ranges on things and everything. It seems they seem to be doing a lot of work in there at the moment. So it's definitely something to keep an eye on. So after we talked about all the cluster setup, we talked about standard and private clusters. Another thing we might want to do is, instead of managing our secrets in Kubernetes, now these are safe, they're encrypted inside of etcd. There's no real issue with that. But if you have an existing process, or simply want to just move all your management and control and controlling access and updating to certificates or keys or anything like that, you might want to do it all in keyvault. And so what's really interesting for tip number 4 is consider using the Azure keyvault provider. So this is a CSI driver, which means that it integrates very tightly with Kubernetes, and it allows us to take a secret and mount it as a volume directly. So we can take multiple secrets and store from different places and store them as a single volume, which may help a particular application. Let's say it's an SSL certificate or a particular sensitive config for connections to external systems. But we could also provide, like I say, it works on Linux and Windows, but also if we don't want to do volumes, we can also actually sync secrets with Kubernetes, which basically means when we change something on keyvault, it will reflect that and update the secret inside Kubernetes. So we don't have to manage and change things directly using Kubernetes secrets. This will kind of do it for us. And also, this then supports this kind of auto rotation of secrets. So how does this work? Well, the basis of it is around what's called a custom resource definition, a CRD, which is the secret provider class. So you define one of these, and inside there is effectively an array of the secrets that you want to be available. So you have the object name, its object type. Is it a cert? Is it a secret? Is it a key? All the usual stuff that you normally have in keyvault. And then obviously, if you really want to, you can specify a version or just use an empty string, which means always get me the latest version. And what that is going to do is provide that kind of route through to keyvault. Yes, you need to provide obviously the client ID and the client secret so that it knows how to connect to it. But in terms of mapping your secrets back, it really is just an array of values inside that custom resource definition. Once that's applied to the system, then when you are, if we're mounting a volume, what's called a direct mount, you can now provide CSI and the driver, give it the driver name of the secret store, CSI, KSIO, and then tell it the name of that secret provider class. So that we've written. So you can have different secret provider classes containing a different array of key values and other things like that. So it's very, very flexible. And what that means is that will appear as a volume mounted into that pod or otherwise. So really, really, really good to know. Obviously, it is a volume. If you are developing, let's say, a .NET application or anything else like that, that update, let's say you update that secret inside keyvault, that update is not necessarily going to get reflected down. It's not going to restart that pod. So the application will need some kind of file watcher to detect for changes and other things. They are very common in most programming languages. In ASP, in .NET Core, for example, there is a file watcher now which will be able to reload configuration. Let's say if you mounted configuration as a secret inside of there, but it's just a little sort of heads up, a little bit of extra overhead in terms of the application development in there. But it's just how kind of Kubernetes does things. Now, like I say, the other option is to do the sync secret, which again works with this secret provider class. So, but this time you give it this secret object section, and this effectively tells it the format and the structure of the secret that you want it to produce. So here I'm producing an opaque secret, but obviously you can have ones which are TLS. The normal different Kubernetes secret types are all kind of supported. So effectively, again, you're saying what's the key, and then what is the object name that you're getting from, and that object array that we created in the previous one, we're just referencing the object names from there. So we create our array of objects which are in keyvault, and then we create this secret objects. And what happens is this thing is going to obviously connect to keyvault in the same way that it did before, but now it's going to create a secret inside of Kubernetes. And then that just means from the application's point of view, the pod, I can just do a normal way of how I would normally go and get a secret. So I do value from secret key ref, and I link to that secret that it has created. And so this thing is going to keep it in sync. And then I can use it to mount things like an environment variable. For example, I've got secret underscore username, which is going to use my secret and use the key username for that. So that's really, really good, really useful. It is different because, basically volumes get updated by Kubernetes when they update. Like I said before, it requires a file watcher to upload, whereas environment variables are not updated by Kubernetes on update. You'd have to restart the pod. Now, there are various third-party solutions to work around this so that when one thing changes, it automatically kicks or restarts that pod, or you could build an internal controller that did that. But it's worth noting those two things. So if you're looking at an application and how you develop it, sometimes pulling the config from a file rather than using environment variables can be preferable, because if we are mounting those secrets as volumes, then Kubernetes will automatically update those things. And then if you're using this the Azure CSI keyvault provider, it's going to be updating those volumes for you as well. But we just need that file watcher on there. The other thing to note is when you do a direct mount of a volume, again, that data is mounted directly to that volume. Whereas when you're using the sync, there it is making a copy of that secure data. So it is something to kind of think about in terms of, is that what you want? If you want Kubernetes to hold no secret information from that key vault, then the secret syncing is probably not for you in this case, and you probably want to do that direct volume mount. But obviously that has a knock-on effect to how you develop your application in the first part. So it's just this idea of planning a little bit ahead, trying to understand what the needs and desires of the system are. Like I say, it does support the auto rotation of secrets. This is an optional flag. I think it's turned off by default because it's like a preview feature at the moment. But it will just means that if I update something on the key vault, it will automatically push that through to the server automatically without me having to restart or do anything to the pod. It's worth investigating, and how often it checks for new values and other things like that. So yeah, it's a very, very useful kind of tool, especially if you want to manage that thing. And like I say, it's where you want to keep your data, and how private you want to keep that data, and how many copies of that data you want to keep around. So the next thing we're going to talk about is container security. So like I say, you've got your cluster, and we've looked at all the different parts of how we can try and make that secure. But the containers themselves, you've got two parts to them. You've got the operating system the container runs in, is it Alpine, Ubuntu, whatever, and then you've got your application inside of it. So you've got this extra layers of security that you need to worry about, as well as the actual cluster itself in terms of malicious code. And so really sort of tip number 5 on here is not running containers as root. It should be fairly obvious, but at the same time, it's very easy to forget the container is running as root. From a Docker point of view, you can set the user to, obviously you can create your own user. You're not a non-root user when you are building the image, or you can use a kind of default built-in user just by a number like user 1000 in this case. So that's just, if I was specifying it in the Docker file, I can just set the user right at the end of the command. So anything that runs before would be ran as root. Let's say your container runs as root. Generally, you're able to move things around, change system, maybe install security updates, do all that kind of stuff. But then when you get to that last command, because obviously Docker files just run top to bottom, is we just switch into that user 1000, and from that point on it runs as that user. So we can do that at the Docker file level. The other option is to do it as part of the kind of pod specification inside the security context of that particular container. We can run as user and give it a particular user to run as. The other thing to notice is not in the container security context, but sort of outside of that there is another security context where you set the file system group, which could also be 1000, which is one thing that sometimes you can miss, and then you get into a bit of a mess in terms of who has write ownership or read ownership of files on the file system. So it's just two parts to be aware of there. Now, obviously, while we're in this security context, there are other features in here that are really sort of useful to have on. Capabilities are kind of system level capabilities, and by default, really, unless your container needs to do something very, very kind of specific at the sort of OS level, it is worth dropping all of the capabilities unless you actually need them. Now, I know if you are doing debug or need access to very high system calls, you can do this, but obviously you could build that into a Helm chart or have that as an optional kind of flag whether you do it. But generally, you want to drop all of those capabilities just for security sakes. And then we want to mark it very explicitly as running as non-root, which is true. We're doing that anyway through the user, but it's worth putting in there again. And then obviously allowing privilege escalation to false, which means from a regular user, I can't sudo up into a root user and start doing things, because you don't want somebody to be able to suddenly start changing things. Now, this can cause an issue if you are trying to debug things, if you're trying to go in and maybe look at certain things that you do need to be a root user of. But like I say, again, putting flags and switches into these things so that you can switch in and out of them is all part of your sort of application design and other things. But it's really good to have this as the default. And if you run into errors, then you investigate and work kind of backwards, but you end up with a good starting point security wise. So the other thing we can look at is using something called App Armor. Now, this is applied at the node level. So if we had a particular node where we're going to be running sort of restricted containers, or they have some other kind of access, and we'll be absolutely sure that things are kind of locked down, is I would need to SSH directly into the node itself, into the AKS node itself. Now, like I say, that can be done, via the jump box because it's on the same network. Like I say, if you're running a standard AKS install, you may have to create a jump box just to get in and get to that SSH or access it through the portal or other things. But once we're in there, what we would be doing is creating an App Armor profile. So App Armor is a very sort of common Linux level things it works with pretty much, I would say, all versions of Linux. You can see here we create this profile, and this here is called K8s deny write, and what it's going to do is not allow any writes to any files. And what happens is we apply that to the node, and Kubelet, which is the thing that starts up all of our containers, it's going to use that profile as part of it, and then if anything does try and write to the file system, it's going to block that file because we have that App Armor in place, and it just allows that extra level of security in terms of the file system or the processes that are going on inside. App Armor is an extremely large topic, but it is standard across all sort of Linux versions. So understanding how you create and the options inside of the profile is pretty easy to find out. Also, once that profile is in place, like I say, we can go into our pod, and then for a particular pod, we can use the annotations with container, App Armor, security, and then give it the name of the profile that we created and refer to it. And that means when that pod runs, when Kubelet runs that pod, it will apply the App Armor profile to it. So like I say, as soon as anyone tries to write to the file system with that pod, it is going to block it or error that pod and not allow it, which is great sort of security. Obviously, you have to be careful if you're trying to write logs to the thing. It's gonna fail, but it's all part of the design of your system about how what and that pod should be doing or should be allowed to do. The other kind of, there's two sides of the same coin, really. The other thing is setcomp, which is a little bit newer. This again is applied at the node level, whereas App Armor is a sort of operating system level. This is kind of at the process level. So with this one, let's say we want to prevent people from chmodding. We don't want to change people. We don't want people to be able to change permissions on particular files. And again, it's a kind of sort of profile thing. In setcomp, they're called filters. We can create one and apply it in the same way, SSH into the node, create a file, put it in the right place so that setcomp can find it. And then when Kubelet starts up, it's going to be able to read that filter, and then we're going to be able to turn that filter on for a particular pod by again providing the information as part of the annotations. And this way we can turn off particular features, particular processes for certain users within there. Like I say, if you've got very sort of risky nodes or certain workloads running that you need to be absolutely careful about, or people have certain levels of access and you want to be really careful about it, then this is a really good way to do it. So yeah, Linux node level security. So tip 9 is should be fairly obvious, but regular container scanning. So there's various companies out there who provide different container scanning software. Black Duck, Snick, White Source, Aqua. There are more. Some do source scanning and container scanning. Some do binary file analysis as well. And all of them give different reports and other things. Some are more expensive than others. At Cluedin, we use Black Duck. And what happens is every time we create a container, we push it through Black Duck. And the idea with container scanning is they are matched against a large set of vulnerabilities. And you can see here, this has caught that there were 4 high ones in here. A lot of the time, sometimes it just involves running the Linux apps update and upgrade on these things because the fixes have been released. Other times you have to go in and maybe specify a particular version. So on this one, we can see we've got a new vulnerability in here. It's marked as high. I can open that up and find out more about the security that it involves, but also if the container scanner is worth its salt, or if one exists, because it might not, but it should be able to suggest a fix, a version fix for those. So I now need to go in and update that Linux PAM to 1.4 to cover off that thing. And it also allows us to do reports, as well as doing kind of security risks. There are what's called operational risks in terms of licenses. Maybe you're using a license that is considered risky for the business and other things like that. So there are levels of scanning. Like I say, there's kind of basic levels, there's source levels, binary scanning, which will look deep inside the DLLs and do all of that. It's really, really useful to have as part of that kind of workflow. Like I say, it is another extra cost, but I think for the sake of what it can pick up, being able to do reports, and obviously this sort of continual improvement that you can do along the side. Obviously, with a lot of our customers, we are asked to produce security reports and give security reports for each version that we release. So having this is very, very useful for us, and it makes sure that before we do a release, we can tick off all of the things and work through any of the security issues that we might have ran into along the way. So as part of that, one of the other interesting things is updating images on base image changes. So very much like where you would trigger a build if somebody updated the code. When you're thinking about containers, you can actually set up an ACR task to actually update the container if a dependent image works. So if you have a web application, let's say it's based on Node, let's say that version of Node was updated, then you can create effectively a trigger, a task inside of ACR that will rebuild the container image. Now, this may involve having to have a copy of those base images, because obviously we can't connect the task to a particular container image and check that. Now you can, there are other ways of doing it, but in the scope of kind of ACR and other things, sometimes you might want to have your own copy of your base images inside, so that you're able to set up these triggers for these other dependent things. So you might have your own internal sort of copy of that node container, so that you can apply any security patches to it, which you might not be able to do with the source line one if it's a bit out of date or whatever. And then if you've got like a web application that is reliant on it, then you can, as soon as you build a new version of that, it should trigger a build of that dependent container. Now, the other thing to say is when you are that you really should be rebuilding images regularly, even if there has been no changes. So sometimes we've had images that haven't been touched for a while because there've been no need to change any of them. But obviously, security vulnerabilities creep in over time, and we want to be able to kind of run every now and again. And as part of that run, we'll do the operating system upgrades, like on Linux or Alpine or other things like that. Run their system upgrades to get the latest patches and any OS changes inside of there. And you can inside ACR set up a timer task to run every day. Maybe you would do a build. Everything would still be tagged the same, but maybe a different kind of build number on one of the tags. But it really just adds to those things that you don't leave a container image unattended, where a potential security issue could come in. So having those regular updates is really, really useful. So very wanted to end off with a look at Azure policy. Now this is a very kind of specialized um, uh, set of tools that you may or may not want. You can enable this when you install your AKS cluster. Again, it's done in the form of an add-on. But what does this really do? Now, this is really aimed at people trying to have an understanding of compliance if they have, let's say, an ISO 27101 compliance, or if we're trying to comply in the UK with NHS and other guidelines. These are a set of things that must be done like a checklist almost, that we can apply. We can also look, there's obviously lots of different categories of these groups of policies that we can have together, network monitoring or whatever. We can also pick ones out just for Kubernetes, which has a set of best practices out of the box by Microsoft. And sometimes these are worth having a look at, and understanding what they are actually telling you. I found that some of the times they're trying to sell you other Microsoft services by saying things should be there. They tend to be, using the premium features of these things, but for certain customers, it may absolutely be right. So if we take the Kubernetes ones, for example, let's just pick the ensure security of key and certificate repositories. Okay, that's fine. As far as I can tell, we're non-compliant on there. If I go in, it will give me a breakdown of compliant and non-compliant policies. So what I've done is got an AKS cluster, and when I created it, I linked it to I enabled the Azure policy, and this is why it's reporting on here. So let's take the second one down. Key vaults should have purge protection enabled. So I'm currently non-compliant on that. So if I'm not on there, I can go to my key vault, and if I go into the properties section, I can see that enabling purge protection was turned off. So I can turn that on, I can save that, and then that will run again, and then we will have a fully compliant version with that. And sometimes it's nice to have that checklist of things, especially again in that kind of production environment where you might want to be working through. But like I say, if you are running in a very highly regulated scenario, it's really good that Microsoft provide a lot of these things out of the box that you can kind of work your way through, and it also gives the customer confidence that your system is able to comply with these things, and also that you've thought about them. Also, you can obviously go in and add exceptions and say, this isn't relevant for my application, but at least that you've done the work on there. So, like I say, it's very specific to a particular need, but it's really worthwhile for that kind of security sign off, for that final sign off in terms of that production environment that you might want to have. So that really brings us to the kind of end of the talk today. I really hope you've got some useful things from it. These were the tips that we did, which was restricting access to that API server on a public a standard AKS install. Looking at the application gateway to see if that would help you work with your public load balancer. Looking at private AKS, the complexity of it, but the security of knowing that nothing moves across the public internet, extremely important if you want to keep that cluster completely private and secure. Looking at the Azure Key Vault provider for managing your secrets in Key Vault rather than in Kubernetes itself. And then some container work, which is like not running containers as root, turning off privilege escalation, and then using things like AppArmor or SepComp to make sure certain processes or certain features of the operating system don't get you into any trouble, and you can really lock those down. Regularly doing container scans is really, really important. Make sure those vulnerabilities are all flagged and taken care of. And then finally, updating the images on base image changes and making sure that you regularly update those container images that you've got on there. So I hope one or more of these is useful to you. I hope this has been an interesting talk. I hope you've managed to get something from it. And thank you very much again for having me here today. I really appreciate being able to speak. It's been a little while since I've done it, and I'm just getting over a cold, so I'm very sorry if I've been a bit hoarse voiced. But if you've got any questions, please feel free to drop me a line, and I will have a look at answering them. And then I will make these slides available for anyone who wants them. So thank you very much and have a good day.